Welcome, and we're working on the scale factor in geometry. The scale factor is the ratio of two corresponding side lengths of similar figures. Key thing here is similar figures. As you can see from my right side here, I have two objects that look like arrows just pointing downwards. Similar figures have the same shape, but are different sizes. As you can see, one is smaller from the other or larger from the other one. Use the scale factor to find the missing side lengths of a figure. As this example that I have on the right-hand side, you can see that to go from this figure to this figure, I just have to times 4. So if I'm trying to figure out what's going to be the other side here, the length side, it's just going to be 2 times 4, which is going to be a total of 8. All right, so looking at example 1, example 2, and the rest of these problems, we'll definitely practice through some of the work on this. So for the first one, you need to figure out what is it being multiplied to go from the smaller shape to the larger shape. And usually they give you two of the sides that are obviously given to you in this case. I'm going to write the 4 there. Now, what you just need to figure out is what is the scale factor. So 2 times what, I'm just going to put W for what, equals 4. Obviously, when you solve this out as an algebra problem, it is 2. Basically, to go from the small square, which is A, to the large square, which is B, they're just timesing, sorry, that's a times, by 2. So if they give me the large one, if you notice now, they're giving me the larger one, how do I go backwards and find the other side? I'm basically just dividing by 2. So in this case, since they're both perfectly squares, the question mark is going to be a value of 2. All right, moving on, I can look at some of the other shapes like triangles and some other shapes from here. As again, I like to go from the small shape to the larger shape. To go from 7 and figure out what's the scale factor that multiplies and gives you 21, just divide it out, take 21 divided by 7, and it's times by 3, times by 3. If I want to go in a backwards order, though, if I want to go backwards from this, I just need to divide by 3. So 18 divided by 3 is 6. Again, I can do this with multiple shapes. This one, notice that it does have two question marks, so I do have 2 questions on this problem. To go from the small triangle to the large triangle, I just have to figure out what do I have to multiply by. In this case, I'm just multiplying by 4. 4 times 12 will give me 48. Now, to solve the rest of them, if I wanted to do this side first and figure out what's the length of that side, I just have to take 8 times 4, which is 32. That's the solution on this one. However, whenever I'm working backwards, I want to go from this direction, I just have to divide by 4. So 32 divided by 4 is 8. This just happens to be an isosceles triangle since I have this side is 32, this side is 32. They're actually the same thing. What's catchy about this, or what's kind of tricky about this, is that you have to kind of analyze and figure out the picture on this last problem. Notice how this angle is congruent to this angle. So what I have to imagine here then is that which side is which matched up with which shape. The triangle is basically just flipped upside down. This 5 corresponds to the triangle. I'm sorry, corresponds to the question mark. Let's figure out the size, the growth scale factor first. So if I take 4 times what equals 14, divide by 4, I get 7 over 2, or you can write 3.5 as the answer there. So the scale factor on this is 3.5. It's multiplying this triangle by 3.5 to get to this size. So if I'm trying to figure out how to take this and get down to the question mark, I just simply have to take 5 times 3.5, which will give me 17.5, and that's the answer to the question mark. All right, thank you very much.